Alright, let's talk about real numbers. They are for real. So if we're reading down our chart or from the outside in, then we want to use the word sum. So for instance, some real numbers are rational. Some real numbers are integers. Some integers are whole numbers. Some real numbers are natural. So we read it outside in. We could even say some rational are integers. Some integers are whole. Some whole numbers are natural. Okay, so we read that. Use the word some as you're reading from the outside in. And as we're reading the other way, so if we're reading from the inside out, then we're going to use the word all. So all irrational numbers are real numbers. All integers are rational numbers because that's outside of it. All rational numbers are real numbers. We could say all natural numbers are whole numbers because natural numbers, this circle is part of this larger circle. I guess it's an oval. So it's part of this larger oval. And all the whole numbers are part of the larger oval of integers. So all of those make up the integers. So we'd say all whole numbers are integers. All integers are rational numbers. All rational numbers are real. So if we're reading it inside out, and that's how we should classify. So if we were classifying numbers, like let's say if we wanted to classify, let's say -1. Classifying -1. -1, is it a natural number? So always start inside out as you're classifying. Inside out. So is -1 a natural counting number? Like 1, 2, 3? No. Is it a whole number? Like 0, 1, 2, 3? No. Is it an integer? Yes, because that's -1, -2, -3, 0, 1, 2, 3. Those are all types of integers. So we'd say yes to integer. So it's an integer. Now let's keep going out there. So it is a rational number because if it is an integer, it's also rational because integers make up the circle for rational numbers. So we're going to say it's an integer, it's rational. And then if it's rational, we already know it's what? It's real. So those are our three answers. Integer, rational, and real. And we can try another one there. Let's classify the square root of 25. Well, what does that reduce to? What number times itself gives you 25? 5. So if we classified 5, we would say 5 is, start from the inside out, so 5 is going to be natural because it's a counting number. If it's natural, it's also a whole number. If it's a whole number, it's also an integer. So all whole numbers are integers, all integers are rational, and all rationals are real. So we're going to say it's natural, whole, integer, rational, and real. The only thing it's not is irrational. Alright, I'll do another example. If we had to classify 0.121212 ... Well, look at that number. Does anything repeat? Yeah, and if it repeats, you should be able to put a bar over it. So the 1 and the 2 both repeat. That's why we have 12, 12, 12. So that's repeating. And anything that's repeating is rational. So it's not a natural number, because 0.121212 is not a counting number. It's not a whole number, because it has a decimal. It's not an integer, because it has a decimal. But it is rational because it repeats. And if it repeats, we know we can write it as a fraction. So it is rational. If it's rational, it's also going to be real. So we're going to say rational and real are those two answers. Alright, and then our last example, let's say the square root of 19. Can you think of any number multiplied by itself that gives you 19? Well, 4 times 4 gives you 16, 5 times 5 gives you 25, but there's not a whole number, so that is going to be irrational. So if you have a square root that's not a perfect square, or one that comes out evenly, like our 25 did, because 5 times 5, nothing times itself gives you 19, or no whole number times itself gives you 19. So it's irrational. If it's irrational, it's also real. Again, this is how you look at it. Is it natural? No. Is it whole, integer, rational? No. So we got to look over here. Is it irrational? Yes, because it has a decimal that doesn't repeat or terminate. And remember, those are all the square roots and any number that has pi. So it's irrational. If it's irrational, it's also real. And I will go over one more confusing one. If you had like 0.34334, 3334, ... this number, you can't put a bar over the 34, because if you did, that would mean this next number was 34. And this would have to be 34, and that's not the case, is it? So nothing is repeating there, and the ... means it goes on and on forever. So this one's also going to be irrational, because it never repeats, it never terminates, and if it's irrational, it's also real. Alright, well that's how you classify real numbers. I hope that helps.